So as I was saying, what happens is that the two things take turns. Okay, they take turns. And when they take turns, that is where the rotation happens. So what I was trying to demonstrate, if you have this blades, one, two, three, if they are rotating at a point in time, the one will come and take this position, the two will come and take this position, the three will come and take this position. Then the two move from here and come to the three in that order. The one will move from here. The one comes here and then
Yeah,
moves to the three.
come
Hello? Okay. So if we name this one, we name this blade two, we name
here.
this blade three.
Yeah,
Please, can you hear me?
yeah, you come ahead.
Okay. So if we name this blade one, we name this blade two, we name this blade three. When we are rotating or when we turn the fan, if you watch carefully, the fan always turns in one direction. It doesn't go the other direction. By normal rotation or normal turns, you can turn in one direction or the other direction. So let's use the fan's direction, which I think is going towards um the right. It's going towards the right side. So what happens is that at a point in time, this one will now come to this point, and this three will now come to this point, and this two will now come to this point. So it goes on and on. From here, this one will now come to this point, and then this three will now come to this point, and then these two will now come towards this point. That's how they will be turning, right? But when it comes to our graph, we only have the x and y axis, and the x and y axis, and they will be turned. So if they are turning, they will be interchanging positions. That's the major idea of rotation. So if this is my normal graph, okay, if this is my normal graph, and this is the x, this is the y, and this is the negative x, and the down part is the negative y. So if you come to this region one, region two, region three, region four, at region one, you know that always points are written from the x before the y. So at region one, you realize that the x is positive and the y is positive. That's what will happen at region one. What happens at region two? You can see the x here is negative and the y here is what? Positive. What happens at region three? The x is negative and the y is also negative. What happens at region four? The x is positive here and the y is what? Negative. So this is the normal graph that we have. This is the normal graph that we have. So if this is our normal graph, then now, if we are going to look at rotation, so xy is going to take the movement to this region, okay? And if xy is going to that region, what happens? The x and the y will interchange position. So here, originally we have the x and y. Don't worry about the negative, it should still be there. Then the x and y will interchange position. So the y goes up while the x comes down. Is that okay? Now from here, if this is also coming back to the third region, what do you think is going to happen? The x and y will interchange again. X is now down, y is now up. So now here, both are negative. So put the negative signs there and bring the x back up, and then the y will now come down. If this is now moving to this side, what is going to happen? The down is negative already. So the y again will go up. It will take turns again. Y will go up and my x will come down. So if this x is coming here originally, it will come back to x, y, because here x and y are both positive. So the x will now come up again, and the y will now come down. If it is going there, the same issues will happen, and you see that the y and it will now become up again in the yx. That is how rotation happens. So I use the movement and the turnings to create the formulas where I have my xy as the original. So when I made movement, you see, I'm making the movement towards the left. If your movement is towards the left, we call it anti-clockwise movement. If your movement is towards the right, we call it clockwise movement. So in that case, I have xy here. I don't have to choose any formula. Now the xy became what? Like yx here. When I moved it, when I turned just once towards the left. So any turn towards the left once is called 90 degrees anti-clockwise. So for 90 degrees anti-clockwise, we'll have negative yx as our result. Then this is also another 10, 90 again, that makes it 180. So this is now 180 degrees anti-clockwise. And that will now become what? Negative x, negative y. Then this is now 270 degrees anti-clockwise. And that will become y negative x. This is 360 anti-clockwise. And that's xy again. This is, you come back again here, it is 360 plus 90, 450 anti-clockwise. Then plus 180 plus 90 again, 450 plus 90. I think it will be 540, 540, and so on and so forth. So last year, for instance, the BC, one question came up in the section A. They asked students to rotate a point 360 degrees clockwise, and students were confused. If you are rotating 360, it means that you are coming back to the original position. You can see 360 is still XY, like this one. And that is it. So it means that the point will still be the image. 35 will still be 35. Yes, so that is how it is. So that is the whole idea about rotation. But if you are going towards the right direction, so what happens is that this part from here to here, this becomes what? 90 degrees clockwise. Then if you add one more 90, it becomes 180 degrees clockwise. If you add one more 90, it becomes 270 degrees clockwise. And if you add one more 90, it becomes 360 degrees clockwise. Is that okay? So now you realize that 90 anti-clockwise is the same as 270 clockwise. 180 clockwise is the same as 180 anti-clockwise. So in most questions that they ask, they can only ask you to rotate 180 degrees without telling you clockwise or anti-clockwise. I've seen students raising their hands saying that there is an issue with the question and are they to rotate clockwise or anti-clockwise, forgetting that if you're rotating 180 degrees, be it clockwise or anti-clockwise, the rotation is still the same. Is that okay? So 180 is clockwise is the same as 180 anti-clockwise. So we can just ask you to rotate 180 degrees. Then we have 270 degrees anti-clockwise being the same as 90 degrees clockwise. Good. So these are the formulas. So this is the original, so we don't need it. Don't need them. And these are the actuals. XY. The summary of whatever I have done is this. You know, the original is XY, so you leave it there. So you know that when it comes to this point, the x is negative. When it comes to this point, the y is negative, the x is negative. When it comes to this point, the y is negative, the down is negative. So now from xy, just turn it. So if you are turning it, come here, it becomes y x. Then the y x, if you turn it, it becomes x y. Then the y x, x y again, if you turn it, it becomes y x. And you are done. That's your formulas. So this is the original graph. Original. So this is the original. So if you want 90 clockwise, you just come here, and that is here, y neck x. If you want 90 anti-clockwise, you come left, and that is the neck y x. If you want 180, that is here. So this is 90 anti or 270 clockwise. And this is 180 clockwise and anti. And this is 90 clockwise, 270 anti. And that's the summary. So these are the formulas that you need for rotation. Is there any questions so far? Hello, Mr. Benjamin. Please ask them for me if there's any questions so far about getting the formula. So you don't have to chew anything. If you just draw this somewhere, you can get all the formulas that you need. Please, is there any question?
Not at the moment.
Okay. So now I made mention that if you are doing rotation is about a fixed point. A fixed point. You rotate about a fixed point. So all of these that we have said, if the rotation is from the origin, then you just have to use the formulas and then you go your way. To rotate, then you go your way. But there is a different kind of rotation where the rotation is not from the fixed point. It is one thing that you must also know. Rotation not from the fixed point. So if I ask you to rotate a point, let's say A, X, Y, about the fixed point AB, which is not the origin. If you just go ahead to rotate, you would get it wrong. So I've summarized it with the acronym SRA, the abbreviation rather, SRA. So we use the SRA approach to rotate about a fixed point, which is not the origin. So SRA, how is it going to be used? S is subtract, R is rotate, A is add. So subtract the fixed point from the point you are about to rotate. So the first step, step one, you subtract. So XY minus AB. You know, if you are subtracting 2 points, you subtract their x components. So that will be x minus A for the first one, and then y minus B for the second one. This is what you have. After you have gotten this, step 2, rotate the answer you got. Rotate the answer you got here. So step 2, rotate the answer. So let's assume that we are rotating 90 anti-clockwise. If you're rotating 90 anti-clockwise, you know 90 anti-clockwise is negative yx. Negative yx. So in that case, the y part, which is this part, will become negative. So negative of that y part, y minus b, comma, then the x part, which is x minus a, is the same thing. Right? So this is what you get at this point. I'll use numbers very soon, so don't worry. Then the step 3, what do? We add. Add the point you are rotating, the point here, the fixed point, to the result. You see here you subtracted. So you just redo what we have done by now adding. So you now have negative y minus b plus the a. Then you have x minus A plus the B. And that will be your answer. Then you would have to plot that particular point at the result, SRA. So step one, subtract. Then step two, you rotate. Then step three, you add. Let me use numbers. Using letters, I know it's confusing some of you by now. So let's take a question like this. Rotate point A, 5, 3, 90 degrees anti-clockwise by the fixed point -2, -1. So you are rotating point A, 5, 3, 90 degrees anti-clockwise by the fixed point -2, -1. So how do we rotate this? So once you are seeing that the fixed point is not the origin, in the other question, they'll say rotate A, 5, 3, 90 degrees anti-clockwise about the origin. When you see it that way, don't worry yourself. Just go to the formula to use, rotate, plot, you are gone. That's a very simple one. But if they say rotate about the fixed point, neck 2, neck 1, then they put you into a tight corner where you must use the SRA. So step one, I'm going to subtract. So what's the point I'm rotating? 5, 3. I'm going to subtract the fixed point, which is neck 2, neck 1 from it. So that gives me 5 minus the x is neck 2. Then I have 3 minus the y is neck 1. So all this gives me 5 plus 2, and that's 7. 3 plus 1, that's 4. Believe you know it now. When two signs are in between the numbers, and you just make it 1. If they are both negative, it becomes positive. If they are different, it becomes negative. So both are negative here, so it becomes what? Plus. So 5 plus 2, 7. And then 3 plus 1, 4. So that's my answer for step 1. So I quickly go to step 2. And in step 2, what I'm supposed to do is to rotate this 90 anti-clockwise. So how is 90 anti-clockwise rotation done? You saw from what we did that it is negative y x. If you don't get the formula right, your answer will be wrong. So 7, 4 should become negative of the x, which is -4, comma, and then negative of the y. Sorry, y is 4, so negative of the y first. Then x is 7. That will follow after. So step 2. So step 2. Like 4, 7 is our answer. Now step 3, we are going to add. So the answer is net 4, 7. We're going to add the point you subtracted, the fixed point, net 2 1 that you subtracted. We're now going to add it up. 2 net 1. So we are going to add. So it's going to be net 4 plus net 2, which is net 6. There is 7 plus net 1, which is what? 6. So the image is net 6, 6. And that is what you are going to plot. Are we there? Do you get it? Any question?
Yes.
Any question? I'm not used to teaching and no questions are coming. That's why I keep impressing if there's any question. If there's any area that you have issues with, you let me know so that I can re-echo it for you. And normally, if you teach and the students are not asking questions, I see the challenge from you are only looking at how the thing is done, and then you are achieving how you'll be able to replicate the same procedure. And that is what makes maths interesting. If you are chewing the steps, when the questions change a bit, you wouldn't be able to answer. So you have to understand. That's why I took time to explain the rotation idea, where the blades are taking turns, where the rotation is about a fixed point. Before I came to the diagram, before I'm coming here. So if all you do is to chew this, if I twist the question a bit, you'll be lost. Any questions? So if you have any parts that you don't understand, let me know so that we can address it. Any question? No question. Okay, that's fine. So that is all about rotation. So if you go to enlargement also, we always enlarge about a fixed point. So if you are enlarging, you enlarge about a fixed point. So in that case, when you are enlarging, what do? You only multiply the point by the scale factor. Scale factor is k, it's always there. So assuming I want to enlarge a xy by the scale factor k, my image, and let's say I'm doing this about the origin. So my image becomes k times xy, which would now be k times x, kx, then k times y, ky. And that ends it. So if I'm enlarging a to 3 by the scale factor k equals -3, if I want the image, it's very simple. -3 times 2 is -6. -3 times 3 is -9. So my image is -6, -9. And that ends it. Is that okay? But there becomes a challenge also if you are enlarging about a fixed point. Let's say I want to enlarge a to 5 about a fixed point 3, -4, and with the scale factor k being equal to 3. So that part 2, I always simplify it as SEA. So keep SEA also in mind. Subtract, enlarge, add. Subtract, enlarge, add. So step 1, you're going to subtract. So that will be 2, 5 minus 3, -4. So 2 minus 3 is -1. Then 5 minus -4 become 5 plus 4, 9. Is that okay? 1 1, 9. Then step 2, we are going to enlarge this by the scale factor k equals 3. I'm going to multiply -1, 9 by 3. And that's 3 times -1, -3, 3 times 9, 27. So that becomes -3, 27. Then now step 3, I'm going to add. So step 3, I'm going to add. So add up. So you have -1, 9. Sorry. Is the answer I'm going to add. So -3, 27. Then we'll add the fixed point to it. 3, -4. So -3 plus 3 is going to give us 0. Then 27 plus -24 is 23. So our image is going to be 0, 23. So if you have it graphically, means that you have about 3 points. Let's say a triangle. So you do this to the first point, do this to the second point, do this again to the third point before you can get your image. But if the enlargement is about a fixed point, where they say enlarge A25 by the scale factor K equals 3 about the origin. And it means that you don't have anything to lose. You don't have to do SEA. You just go straight to multiplying the point by the scale factor and you are good to go. Only step 2 holds. And the reason is this. Let me explain that. If it is about the origin, it means that the origin is always 0, 0. So 2, 5 minus 0, 0. You are still going to get 2, 5. If you enlarge this by the scale factor 3, you are going to get 6, 15. If you add 0, 0 to 6, 15, you are going to still get 6, 15. So you see that step 1 did not affect the answer, and step 3 did not also affect the answer. It was only step 2 that affected the 0.25. That's why we don't worry ourselves coming back to go through these 3 steps again. But you just do the second step by multiplying by the scale factor, and then we are good to go. Any question about enlargement? Yeah, please, can we exit and then join again?